So a couple of years ago, I joined GitHub as an engineer, and one of my strongest memories of onboarding at the company was when I first cloned down our code base and saw our pretty typical monorepo with one very unusual aspect. And it was that there were over 1,000 custom linters inside of the code base. This was unlike anything I had seen before in my career. There seemed to be a linter for everything you could think of, and honestly, there were linters for things I never thought could be linted. So for someone who really likes linters, this was like walking into some sort of alternative universe where all of my dreams had come true, or so I thought. So my goal today, first and foremost, is to just share that sense of wonder and awe with all of you when it comes to how GitHub uses linters. But first, quick introduction. My name's Joel. I live just outside of Boulder, so actually very close to where we are right now. As a Colorado resident, I'm required to show you a picture of me and my dog on top of a mountain. So this is my lovely golden retriever, Captain, and I on top of the Grand Mesa out on the western slope of Colorado. If you have a little bit more time while you're here in Colorado, I highly recommend a trip out there. It's absolutely beautiful. So at GitHub, I'm an engineer on the design infrastructure team. We're a group of designers and engineers that build and maintain Primer, which is our design system. But I'm not going to talk about that today much at all. So anyways, let's talk about linters. Today I'm going to talk about how we use linters at GitHub. I'll talk about why we use them. And I'm going to give the main bulk of this talk is actually just giving a ton of examples of all the different kinds of linters we use. I'll share some things we've learned along the way. And that's kind of the gist of the outline. But first, I kind of insinuated this, but big disclaimer, this is not meant to be an example of what to do or not to do. What we do at GitHub probably doesn't make sense in a lot of other code bases. Think of this more of as a window into the reality of where we've ended up after however many years we've been building our code base, and take from it what you will. So with that in mind, let's start with some context. Our monorepo is now well over 14 years old. I think it's actually over 15 at this point. We recently crossed our millionth commit in our monorepo, and it's a ton of Ruby. I actually found a really cool tool called Clock that you can use to measure the number of lines in a code base, and we clocked in at 2.5 million lines, and that is excluding comments and blank lines. So this is a ton of code. And perhaps most importantly, we have over 1,000 unique people contributing to that code base every year. Massive scale. So that's a bit of context about my work environment that should help you understand where I'm coming from when I share some of these examples. So before we get too far along, let's make sure we're on the same page about what a linter is. So I'm going to start with the Wikipedia definition, which is a static code analysis tool used to flag programming errors, bugs, stylistic errors, and suspicious constructs. I want to know who wrote those last two words. I think they're kind of cheeky. But more simply, the definition I like to use is that a linter is just something that gives you automatic feedback on your code. So why do we use linters? At GitHub, our scale that I just talked about is a big driver of why we use linters so much. When we have over 1,000 engineers pushing so much code, linters enable us to ensure our code base is held to consistent standards and practices that we care about. But the main reason we write linters is to provide high-quality feedback. And when I think about feedback, there are many different ways of judging whether it's good or not. But for the sake of our discussion today, I want to focus on three specific attributes. The first is that good feedback is specific. It's easy to understand, and it's narrow in its focus. It's also timely. Feedback is the most valuable when it's given at the right time. And last, it's actionable. There's something that you can do when you're given the feedback that will help you improve. So let's dig into some examples from our code base, and we'll basically evaluate them against these criteria. So one way that we write linters is what we call nudges. These are actually really more of a precursor to what you would consider to be a traditional linter, but we use them to provide automated feedback all the same. So we write our nudges with a tool that we call Sentinel, and we originally built this to just provide what are effectively automated code reviews on pull requests. You can think of it as literally a set of regular expressions that when they match, return a certain message that is left on a line of code on a pull request. We currently have about 100 of these in our in our setup. So here's one example from my colleague Kate Travers. And the rule she added was to prevent leaking information in templates. We had this problem where people would write HTML comments that would put out some information, say about a database record, that we didn't want to send to a customer, and people wouldn't make the connection that that HTML comment was actually going to end up in front of a customer. So basically what we said is, this is bad. Let's encourage people to use ERB comments which are not returned to the customer. So here's what that looks like. This linter is literally just configured with a giant YAML file that lives under version control. And we have a name and a title for each of our rules. So in this case, we have the HTML comment title, and then we have a pattern that matches the beginning of an HTML comment. And the bulk of this rule is really just the comment that it leaves on pull requests. So this is what it looks like in action. It's a GitHub bot called Sentinel Reviewer, and it looks at a pull request and it says, hey, I'm going to leave a comment on this offending line. Now, the thing that gets interesting about these nudges is that we use them in these cases when we don't want to fail the build, and it's because we're not necessarily very confident in them. So if you look at this line, this is not a security issue. It's not great that we're just like, when someone's looking at our source code, they're going to see this line. Like, it's not super clean, in my opinion, but it's not going to leak sensitive information. So another way we use this tool is to trigger pull request reviews. So for example, the team that I work on actually owns the stylelint linter at GitHub. And we use this tool to flag changes that disable that linter on a pull request. And basically what this does is that instead of leaving a message, we can add this request review flag, and it will pick the GitHub team that should be requested for review on the pull request. What's really cool about this is that it's effectively it's like a regular expression code owner. So instead of having ownership of an entire file, you can say, I'm just going to care, my team cares specifically about when you use a certain syntax. So those are some examples of how we write our nudge type linters. If we think back to those criteria for good feedback, how do these stack up? So they're kind of specific. They look for a particular problem, but they aren't necessarily confident. That's why we're not blocking the build on these. They also aren't especially timely, as they only run once you open a PR. They're built with a GitHub app, and they run. This is actually an app that exists outside of our monorepo. And they're actionable basically to the extent that you can write a good message. So like, if you can write a great message that says, I see you did this thing, here's the exact right thing to do, given this case, great. Like that's pretty actionable, but it varies greatly based on what you're looking for. So another way we write linters that I had never seen before coming to GitHub is actually we just write tests that happen to be linters, like literally using Minitest, which is wild to me. Some people have told me that this is common. I'd never seen it before. And these are literally just tests that make assertions about the static state of our code base. We have hundreds of these. I actually think it's way more than 300 at this point. But here's one very simple example from my colleague John. It's a linter that he wrote to encourage people to use more inclusive language in our code base. So we've decided, like many people in our industry, to avoid the terms whitelist and blacklist whenever possible. So you can imagine you can define a regular expression that you could run over many lines of code to discourage people from using those words. So that's literally what we did. This is literally just a test that sits in our code base. It greps for that regular expression of what we want to avoid and asserts that there are no matches for it. So what's really cool about this is like you basically have 5 lines of code that you can write in any test framework you want that will ensure that you use inclusive language. We didn't have to go out and roll some sort of custom tooling for it. As you can imagine, we also have similar tools to avoid profanity in our code base that was once quite common. So a more complex example is from Adam Robin that discourages the use of the HTML safe method. So what we do in this is we use the cert operator method, and we grep for the HTML safe method using a little regex here. And then we assert that it is less than, the number of lines that match that are less than this constant that we define in the file. And if not, we display, as you can imagine, a nice helpful error message that says why we want to avoid this method. This setup does kind of a similar thing to what you're seeing with the nudges, in that it allows us to ensure the right team is pinged to review exceptions to the linter, because this file that contains that constant has a code owner, and that code owner is the team that cares about that specific violation. So whenever you make a change that violates this rule, you go in and you update the integer value of that constant, and that causes the team that cares about it to be paying to review your pull request. But there's a real problem here. These kinds of linters have led to a ton of pain for us. This is actually one of the real kind of downsides we've seen from our aggressive use of linters, is that this specific type has caused a lot of friction, especially when they change a lot. And it's really just comes down to a simple matter of how Git works. And that, so like, say we have this constant here and its value is 50. Say a colleague and I are both teaming up to work on this linter together. Before either of us make our changes, the value is 50, and then we each cut a branch, and I remove 5 cases and my colleague removes 10. When we go to land our changes, there's going to be a conflict in that line. And it's not a conflict that Git can resolve, because it's actually a result of running the linter. So what you need to do then to resolve these conflicts is to actually go check out a branch and rerun the linter and update the count to be correct. This can be especially painful as we're deploying these changes one after another, say on a single day. As you can imagine, repeat this now with 4 people, and it's incredibly painful. And like, I was talking to Eileen about this earlier, and one of the things she said is that like, the last thing we want to do with a lot of linters is make it harder for people to clean them up, because the goal of a linter is to discourage one practice and move people towards the correct practice that doesn't have a linter violation. So it's kind of antithetical to our goal to have friction in this part of the process. So for our high churn linters that really turn over a lot, we really needed a different way. So my colleague Antonio came in with an alternative solution that instead of counters, we would just track a constant that was the list of files that were violating the linter. So here's what that looked like. We had a constant in our test file that just defined a list of template paths. And then he would grep for the offending regular expression. In this case, it was some deprecated CSS. And then we save that as this matches variable. And then it's a matter of just doing an overlap comparison of the allow list and the matches to see if there are any new violations. So what's really nice about this is that it's a step in the right direction from those global counters that is a little bit more immune to merge conflicts, right? Because as you can imagine with this code here, if you were to add additional lines to this constant, Git handles that merge really pretty nicely. There's occasionally some friction with that, but it's certainly a lot better than a single line that everyone's turning all the time. So those are some examples of how we use linters that are written as tests. Thinking back to our criteria again, these linters are kind of specific. Like nudges, they look for a particular violation using a regular expression. But they still aren't that timely because people generally don't run them locally, for better or for worse. And they often get this feedback after several minutes of we actually run these in a separate CI build, but they still get that build feedback after they've pushed and after several minutes. And they're somewhat actionable. Again, like the nudges, they depend on the content of the message. Basically, as good of the message as you can write determines how actionable they are. But we can do better. So the last type of linter worth talking about is those powered by abstract syntax trees. Before we get too far, a brief description of what an abstract syntax tree is. It's a tree representation of the structure of text. In our case, it's source code, right? In fact, all of us learned ASTs in probably 5th or 6th grade English if you went to school in the United States. When you diagram sentences, that is an AST of English. Like I said, these don't, we actually call these ASTs because abstract syntax tree doesn't roll off the tongue. So ASTs. So an example of that is we'll take this line of Ruby, just calling the foo variable or method. Parsed as an AST, it looks like this. So this tree structure is what enables us to write linters that take the structure, like the semantics of our code into account, well beyond what's possible by writing regular expressions, at least with any amount of sanity. So one of the AST-powered linters that we use is called ERB-lint. We use this for our ERB templates. And we've actually written about 24 of these. We just open sourced a couple of them last week, and we're going to start to open source all the ones that we've written. This example that I'm going to share is from my colleague Kate Higa. She's an accessibility engineer at GitHub. So here's the offending case for the linter, and this is my one bit of audience interaction. Can anyone identify what is wrong with this line of code? Back there? He said, is it the fact that there's these weird quotes? Anyone else? Image is redundant. Correct. We have our correct answer. So What happens is that when a screen reader encounters an image on the page, it announces that it's encountered an image, and then it reads the alt text, which means that it would announce this element as image of person jumping in the air. So it's not necessary to include the word image or picture in our image alt attributes. So here's how she wrote the linter for this rule. First, we define a message to return when the linter is violated. In this case, a very helpful message that says, the image alt attribute should not contain image or picture, as screen readers already announce the element as an image. And then it defines a constant that has those words that we want to avoid. So then what we do is, in our linter, we define a run method. This run method accepts a tag object. That tag happens to have a name method we can call on it, and what we do is we exit early if we're not looking at an image. And then what we do is we look at that tag's alt attribute, we downcase it and split it up, and just see if there's any overlap with those redundant alt words that we defined earlier. And if there are, we call this generate offense method that adds the violation to ERBLint. This method is called on every single tag node in that AST we just looked at. One thing that I really want to point out here is that you can access this alt attribute programmatically, which means we haven't written any regular expressions that look for alt equals, quote, etc. It's so much easier to write these linters than it is to use regular expressions. So what's great about this linter is that it gives us this kind of automatic enforcement of an accessibility rule that I was never aware of before I encountered this linter. It also just more generally, because of that helpful message, really helps to educate developers to make them think about accessibility in their work in general. Even if we can't lint for everything that might matter in terms of accessibility, this at least puts it on people's minds. But our most common AST-powered linters, as y'all might have wondered, are custom Robocops, and we have about 125 of these. So here's one example from my colleague Carl. So in our code base, we have the ability to check to see what environment we're running in, and it looks like this. We can call github.test or github.production. As you might imagine, this can be incredibly problematic because if you have code that only runs in production, how are you ever going to know if it actually works or not until you ship it? It's really risky. So we started by writing a message that says, don't do this. Don't branch on that GitHub constant. Your code paths should not differ between test and production environments. And then what we did is we took that offending line and we put it through the Ruby parser, which gives us a Ruby AST, very similar to the ERB AST we just looked at, of our Ruby code. And what we can do then is we can write this magic incantation called a node pattern that you can think of as some sort of hybrid in between a regular expression and a SQL query. It's basically a syntax specifically meant for traversing abstract syntax trees. So I'm going to be honest with you, this is where the technical bits of this talk kind of end in their complexity because this really intimidates me. Like, I've written a bunch of these linters. I still don't totally grasp it. I think that someone finally wrote a guide I understood on it this summer. I think it was the Evil Martians. But it's definitely something that could benefit from a better abstraction for any of you who need something to work on. But the good news is that you don't have to use these node patterns to write custom Robocops. I did not know that for a while. At first I thought, you just have to use this crazy syntax, and if you don't know how to do it, you can't write Robocops. It turns out, actually a lot of our Robocops don't even use node patterns because I think a lot of people find them a little off-putting. So what we're going to do is we're going to rewrite this linter to instead just use normal Ruby instead of the node pattern. So we'll start by putting a debugger inside an onIf method. So like the tag method from our ERB linter, this onIf method is what Robocop is going to run every time it encounters an if node in any of our Ruby code across all 2.5 million lines. And what it does is it's going to accept a node argument. So what we'll do is we'll put a debugger in here, and we'll actually just look at what it's like to inspect that node. So, but first, here's the test case we're going to run. So we have if github.test, do the fake thing, else do the real thing. You can imagine that would be problematic in test versus production. So let's look at that debugger. And we'll start by looking at that node argument. So when we go to print it out, you can see it is literally just an AST node. But if we start to poke around, that node has a ton of methods we can use. Just to give you an idea, there's like, I think, hundreds of methods specifically on node. So like, this is just scratching the surface of the kinds of things you can do with this technology. If we look at the condition method, we can actually see that it's an AST of just the conditional, which is send the test message to the GitHub constant. So let's look around some more. If we look at that condition and we traverse a little bit deeper, we can see that its receiver's short name is GitHub, which is our offending class. And then if we look at the condition's method name, we can see that it's also an offender as well with the offending test method. So if we go back to our linter, this is the code you use to use the node pattern. Let's rewrite it to just use plain old Ruby instead. So we'll add an early return unless, we're basically just copying from the debugger right at this point, saying that if we'll return unless the short name of the receiver is GitHub, and we'll add another early return unless the node's condition is test or production. And then if we get past both of those, we'll add an offense specifically to the node's condition, which you'll see more about that in a sec. So it is possible to write Robocops without node patterns. Some people would say it's maybe not as clever. I personally like to defer to code that looks like it was written for another human. I don't feel like node patterns look like they're written for humans. They look like they're written for computers. So thinking about how these AST linters compare to the other types we've looked at, they're very specific, right? Like they look for a particular violation using the actual language parser inside of Ruby instead of regular expressions, which are a general purpose tool. But what about being timely? Like, this is where AST linters really start to shine. So if you might have remembered from a couple slides ago, we added our offense to the node's condition. So if you look at this error message that we're now getting in our editor, it's only highlighting GitHub.production. It's not highlighting the whole line. So we're actually able to highlight the exact portion of the violation for our linter. And what's great is because this is happening in our editor or IDE, that we have an incredibly short feedback loop. We don't need to go to CI. We don't need to wait for a GitHub app to comment on a pull request. And in practice, we found that this difference is what makes linters something that people generally appreciate at the company. Those previous two kinds, we get a lot of crap for them. Like some people really get annoyed, but when it's right in your editor, I don't know how you could really complain, at least about the timeliness of it. But what about being actionable? This is perhaps the coolest thing I'm going to share today, which is how autocorrection works. So here's an example from Katrina Owen for a specific rule we have for writing tests. So if you look at the top, we have assert equal nil value. We don't really like that. What we really like is for you to just write assert nil value. I honestly don't actually know exactly why, but we're going to look at autocorrection for this lint. So we've already explored how we would add an offense to this, so we're just going to skip straight to the autocorrection. So in the case of Robocop, we implement autocorrection by just defining an autocorrect method on our linter class that accepts a node object and returns a lambda that accepts a corrector object that responds to replace. And you'll see what that looks like in a sec. So just a quick refresher, our goal here is to convert that top line to be the bottom line. And we'll need to do that with a lambda. So let's take a look at the Robocops source and see how these replacements actually work. So if we skip a couple steps, we actually don't end up in Robocop, we end up in the parser gem, which is what Robocop uses under the hood. And this is the exact interesting bit of code, which is this replace method. And this replace method is a method we're expected to call in the lambda that we are returning from our autocorrect method. It accepts a range, and it accepts the code we want to replace that range with. We don't need to get into too much more detail here. So if we go back to our example, our range is just going to be that assert equal nil value line, and the content should just be assert nil value. That's our find and replace, effectively. So let's add a debugger to our autocorrect method and run a test case. So looking at the node, we can see that it's the AST of that line in question. And if we inspect the arguments to that node, we can see that the last argument is value. You actually, if you were to inspect some more, you can see the other one was nil. And lastly, if we call it node.sourceRange, we get a range object from parser, which happens to be the gem we were just looking at the source code of. Conveniently, this source range argument is the exact object we need to do a replacement in Robocop. So if we go back to our autocorrect method, it accepts a node and returns a lambda that accepts a corrector argument and then calls replace on the corrector. So then what we'll do is we'll pass in the node source range for the range argument, and then what our new source code should be. And we can write that code down by looking at what we had from our debugger and saying assert nil node arguments last source. Obviously, this is a very abbreviated implementation of this. It does not handle all the edge cases around where these things don't quite line up, or you might have a nil value or something like that. Does anyone have any questions about that? Cool. So needless to say, AST linters can be very actionable to the point of taking action themselves with autocorrection. So that's AST linters. If you want to learn more about them, I hate to break it to you, but the workshop on writing them started half an hour ago. It's being given by Scott Moore. I won't be offended if anyone leaves right now, but there's a lot of great resources online as well. So in conclusion, we use our linters to ensure our practices are applied consistently through feedback that is specific, timely, and actionable. And I think perhaps most importantly, they give us room to provide higher value code reviews. This kind of automation gives us the space that we need to focus on more nuanced things that we're better at as humans than computers. And really what this does is it elevates the conversation that we have beyond things like tabs versus spaces or using like the GitHub.production method. And I think this is perhaps the most valuable aspect of linters that we need to think about as we introduce them into our code bases. When I think about the collective impact of getting to the point of having 1,000 custom linters, is that it really manifests itself in the quality of the engineer-to-engineer conversations we have at our company. And this goes beyond pull requests. Like literally, when we're talking about code, even in Slack, the fact that we have this agreed upon understanding of how we're going to build things means that we can focus on things that are more valuable to our customers than kind of implementation details. I think this is the real reason why we write linters ultimately. Every time I leave a comment on a pull request now, what goes through my head is saying, do I need to be leaving this comment, or could this be something that's better enforced by a linter? Because I can't be sure when there's 1,000 people contributing to our code base that I'm even going to be the next person to review the code that might be violating the thing that I'm leaving a comment on. Even if I come across that code again or it came across my assignment, I might be on vacation, or I'm going to be honest with you, I don't actually think I could reliably catch the same bug like 100 out of 100 times. I would guess my hit rate would be like probably 75%. But perhaps we need to take a step back from all of this. When I was writing this talk, it really made me think critically about the role linters play in the Ruby ecosystem in general. Said another way, I'm really left questioning the value of them now that we've gotten so far along the path of writing so many at GitHub. And really what it's made me wonder is where does the practice end? It's really given me space to think about why we have these linters in the first place. And it's reminded me of a famous quote, that no code is better than no code. And it made me wonder, what if the same is true about our linters? What if no linter is better than no linter? Maybe the best feedback, even if we're able to automate it, is the feedback that never needed to be made in the first place. And the thing that made me think about this was actually one of the previous examples, and it was a linter that was being used for safety purposes. So we were looking for an HTML safe method. That method, if used incorrectly, can introduce fairly significant security bugs into our software. The problem with using linters to detect something like that is that Ruby is dynamic. It's not statically typed, generally, right? It's not precompiled, yet most of our analysis is static, which means that we are going to naturally have some blind spots, such as metaprogramming and other fun Rubyisms. And those things are really hard to limp for. So what this makes me wonder is how we can build systems that are correct as a consequence of their design, not just because our linters passed. But I think that's going to be a talk for another day. Thank you all for your time. I have 1 minute for, 2 minutes actually, for Q&A. Does anyone have any questions? For Robocop and Parser, so the question is for Robocop and Parser, are we using a fork of them? We're just using the latest, I think. We've extracted a lot of our custom, I shouldn't say a lot, about 1/10 of our custom Robocops, maybe even less, to Robocop GitHub. That also has our shared configuration. We use that for all of our Ruby libraries. But yeah, I think we're reasonably up to date on them. Someone else had a question? Yeah. If I'm going to post my slides? Yeah, they're posted. I think I sent them to the conference already. They're also on my website's public repo. Actually, the entire keynote file is too, if you want to see the whole thing. Yeah.
Do you have a favorite linter? Is there like a good example?
Sorry, I should mention the last question was where are my slides going to be? And your question is, do I have a favorite linter? Gosh. I don't know. I think Robocops pretty cool. Yeah, I think Robocops pretty cool. My favorite linter is actually that I think about is some of the work we're doing on CodeQL, which is intelligent code analysis. That's like it kind of pushes past the like static analysis and attempts to like guess how your program is going to execute. That's some like area that GitHub is doing R&D on right now. It's early enough that like I can't really chat too much about that. It looks like I'm over time now at this point. I didn't realize that the blinking red light meant that I was actually 2 minutes over time, not under time. But I'm happy to answer any more questions outside of this official recording. Thank you all.